While working on our OLED display and LVGL integration series, one of you asked how to change the font type and size for text in LVGL. That's exactly what we are going to cover in this video. If you haven't yet watched the earlier parts where we discussed LVGL basics, code integration, and implementation on ESP32 and STM32 microcontroller, I highly recommend checking those out on the channel for full context. Namaste and welcome back to Avinashi Tech. First, we need to understand what font format files are available and what those files actually contain. Well, there are several formats. The common ones are TTF, OTF, and WOFF, and some other specialized formats exist for niche applications. What's inside these files? Basically three things. Glyphs, the vector outlines that describe how each character is drawn. Metrics, spacing and kerning rules that tell the renderer how characters sit next to each other. Metadata, font name, version, designer info, and so on. So, which format should we pick for our LVGL project? For that, let's jump over to the LVGL font converter. Here, you can see it supports TTF and WOFF file formats. For our use case, I will choose TTF file format cause it's simple, widely compatible, and works well with the converter tool as well. Now, I will quickly download a couple of .ttf fonts file. First one would be Arial, and then Times New Roman Italic, just for demo. Once downloaded, I will open them in the OS font preview. You will notice the preview shows the classic sentence, "The quick brown fox jumps over the lazy dog," rendered at multiple sizes. That's just a preview or demo, so you can judge how your font appears in different point sizes. Remember, the preview text itself isn't stored in the .ttf file. The file stores glyph outlines and the previewer renders them at different sizes so we can see how they will look on the screen. Next, we will load these TTF files into the LVGL font converter and generate the C font files for use in our project. Let's do that now. Back to the LVGL font converter page. Here, I will start by browsing and selecting the Times New Roman Italic .ttf file. Let's give this font source file a name. I will call it times_22. I will then set the font size to 22 pixels. And we will keep bits per pixel at 1 for now. That keeps things simple and monochrome, which is perfectly fine for our SST1306 OLED display. For output format, I will go with C file, since that's exactly what we need to integrate with LVGL project. Now the important part, character range. Instead of converting the entire Unicode table, which would make the font file unnecessarily large, I will select only the characters that I need. Referring to the ASCII table, I will include both uppercase and lowercase letters, roughly from 0x41 to 0x7a. That covers the alphabet in both the cases and some extra characters. Once everything is set, I will click submit, and just like that, the converter generates our times_22.c font file. After this, I will repeat the same process for the Arial font, this time with the size set to 30 pixels, keeping the same ASCII range. And now we have got two ready-to-use font files, Times Roman Italic at 22 pixels and Arial at 30 pixels, which we can directly add into our project. Now this will help us to know how our character appears in different size formats and different font style as well. Once we have our font files, let's move to the ESP32 project in VS Code. Well, you can replicate this in the STM32Cube IDE as well, but for this video's sake, I will just go ahead with the ESP32 project. If you want a refresher on how we set up LVGL on ESP32, you can find the video linked in the top right corner. Now, Let's add the generated font files into our project folder and open one of them. Here you can clearly see the bitmaps of character outlines or glyphs for each character we included in the range while creating this source file. So we have got capital A to capital Z, lowercase a to lowercase z, plus a few extra symbols. You will also notice kerning or spacing rules between letters and some other font metadata. Next, I will make sure these new font files are indexed during build by adding them to the cmakelists.txt file. After that, I will include the .c files inside the main ESP32 source file. One important note: if you plan to use multiple fonts like I am using here, you will need to make some small adjustments. For example, constant variable names inside the font files might clash and give you a multiple declaration error. I solved this by slightly renaming the constants in my times_22.c file. Also, you may see an error related to static_bitmap member in the LV font structure. This is safe to ignore for our use case, simply comment it out. It won't affect the final display result. With that fixed, let's move to the GUI task. If you have been following along, you will remember this task is where we initialize LVGL, set up the display driver, and call LVGL text functions. Inside this task, I created two labels, one for Arial and one for Times Italic. For both labels, I will set the text to just a capital A. Then I applied the fonts using lvobj_setStyleTextFont function and passed in our new font structures one by one. Finally, I aligned one label to the left side of the center and the other one to the right side. Now let's build and flash this code onto our ESP32 dev kit module. Once the flash is done, ta-da! There it is, our capital A displayed in Arial 30 pixels on one side and Times New Roman Italic 22 pixels on the other. A small but powerful demonstration on how easy it is to integrate custom fonts with LVGL on embedded displays. That's it for this video. We explored how to change the font size and style in LVGL and render it directly on our SSD1306 OLED display. If you found this video helpful, don't forget to like and share this video. It really helps more people discover this series. And of course, hit subscribe to stay updated and motivate us to keep building more hands-on embedded content. This is Avinashi Tech signing off. Until next time, keep experimenting, keep learning, and keep updating your displays.